All right, here's our last example. We're going to talk about comparing rates of change over different intervals. So, part A, how do the average rates of change for f of x equals 0.75x squared and g of x equals 1.5x squared over the interval from 2 to 4 compare? All right, so we have a graph. We're going to just do a quick sketch of our f of x function and our g of x function so we can just kind of see visually what it is we're talking about. All right, so for our f of x function, that a value is a 0.75. So we'll multiply our 135 by 0.75, and we're going to get a 0.75 over 1, a 2.25 over 1, and a 3.75 over 1. So let's plot those points. We're at the origin. You go up, and we're just estimating. Up 0.75 over 1 is about there. Up 2.25 over 1 should put us right there. And up 3.75 over 1 is right about there. So let's mirror that on the other side. Up 0.75 to the left one, up 2.25 to the left one, and up 3.75 to the left one. And this is our, which one is this? That's our f of x function. Okay, so we want to compare an average rate of change over a specific interval of that graph with our other graph, which is g of x equals 1.5x squared. So let's identify the a value is 1.5. So a couple things, that a value is bigger. As your a value gets bigger, your graph is vertically stretched more, which means it will be more narrow. So I kind of can predict that this graph is going to be more narrow. It'll look like it's kind of on the inside of what we just drew. But let's go ahead and take that 1.5, multiply it by the 135. That gives us a pattern of 1.5 over 1, 4.5 over 1, and 7.5 over 1. We'll just plot the points that fit in our graph. So we're at the origin. We go up 1.5 to the right one. From there we go up 4.5 and to the right one. And then up 7.5 is way off the graph, so we won't worry about it. Now let's get the points on the left side. Up 1.5 to the left, up 4.5 to the left one. And as we could predict, here's our g of x function. The parabola is more stretched when your a value increases. So what we're asked to do is compare the rates of change over the interval from 2 to 4. Now when we're giving these intervals, we need to remember that's intervals along the x-axis. That's when your input goes from 2 to 4, what happens to your function. So if we were to look at the graph, here's where x is a 2, here's where x is a 4. If I were to just kind of draw these lines straight up, now our graph isn't big enough to see, but we're comparing a rate of change in between this interval. So from here to here for our f of x function, then our g of x, we barely even see it in the interval, but it is going to go up in there. So that's mathematically what we're doing. Rate of change, let's remember, is we're going to find our slope. So you guys have done this. You've done this several times. It was on your exam. You've had it on tests, quizzes, homework, all that good stuff. So I'm hoping that it's starting to feel easier. With the graphing calculator, we're going to use, or I encourage you to use the table of values to get the ordered pairs you need to find slope. Now, when they're telling us that the interval goes from 2 to 4, remember, that's from when x is a 2 to when x is a 4. So we're going to use that 2 and that 4 as the x values for our function. You guys have in the past just plugged in a 2, plugged in a 4, and gotten the y values. You can also just use a table of values. So here's just a screenshot. Here's what that table of values would look like on the calculator. In our y equals, I typed in the function 0.75x squared, and I'm just going to scroll through and I'm looking for the ordered pairs when x is a 2. So when x is a 2, I can see that the y is a 3. And then I'm looking for when x is a 4, and I can see that y is 12. And now I can find the slope, or the average rate of change. So slope is y2 minus y1, so we're going to take 12 minus 3 over x2 minus x1, 4 minus 2. 12 minus 3 is 9 over 2, which gives us an average rate of change of 4.5. So what that means is as our function is moving from 2 to 4, on average, it's increasing 4.5 units. And you can think of that as being over 1, 4.5 units for every unit we move to the right on the x-axis. So it's increasing by 4.5 as we move over 1. It's increasing by 4.5 as we move over 1. That's just average. All right, so we want to do the same thing with our g of x function. We need, here I'll kind of do this so we're separating. We need two ordered pairs. Well, we're using the same interval, so we know we need when x is a 2, when x is a 4. So let's grab that table of values from our calculators. So here we have our table of values from the graphing calculator. We want the points when x is a 2. We can see that the y is a 6. And when x is a 4, the y is a 24. So let's find our average rate of change. We're going to find our slope. y2 minus y1, 24 minus 6 over x2 minus x1, 4 minus 2. 24 minus 6 is 18 over 2, which gives us 9. So when our a value is bigger, our average rate of change is bigger. So that's going to be true. That's what's going to happen with your average rate of change. And so they asked us to compare them. So let's write a comparison statement. We can say the average rate of change for g of x, that was our second function, is higher than the average, is higher than, we'll just say, is higher than for f of x on the interval from 2 to 4 with that x in the middle. Interesting to note, it's actually twice as big. This went from 4.5 to 9, twice as big. One thing to note, our a value went from 0.75 to 1.5. Our a value got twice as big. Just interesting things to take note of. All right, how do the rates of change relate to the values of a in the functions? So when a is greater than 0, so this applies to positive a values, the rate of change will be greater in the function with the higher a value. And then let's just take note that this is true for positive intervals. We just did that on a positive interval from 2 to 4. Okay. How do the average rates of change for f of x equals negative 0.5x squared? So our a value is a negative 0.5. This parabola is opening down. And g of x equals negative 1.5x squared. That's opening down. If you were to look at the absolute values of these, this 1.5 would be a bigger value, so it's going to have more of a stretch than this one. It will be more narrow. And we want to look at the interval from negative 5 to 2. How do they compare? So we can quickly just look at a graph. what we're doing is this one that's more narrow, that is our g of x function, the negative 1.5. And then the one that's more wide is our f of x function. And we want to see how the average rate of change compares on the interval from -5 to -2. So 1, 2, 3, 4, 5, that's from here to here. What are our functions doing between these two values? And we're going to just find an average rate of change. So again, use your table of values on your graphing calculator in class to help you do this. And you can even type both functions in. So here I have f of x in my y1. This was the f of x function, and this was the g of x function I typed into y2. And I can look at a table of values and get the points I need at the same time. So let's find the average rate of change for f of x over the interval from -5 to -2. So remember, we're going to create ordered pairs with those x values, -5 to -2. Let's go to our table of values. Here's when x is a -5. I'm going to go ahead and circle the whole thing. And I want the f of x function, which is this -12.5. So when x is a -5, f of x is a -12.5. And then now I'm looking for -2. Here's when x is a -2. I'm going to go ahead and circle the whole line. When x is a -2, f of x is also a -2. And now we just find slope. So we're going to do y2 minus y1. -2 minus a -12.5 turns to plus 12.5 over -2 minus a -5 turns into plus 5. So we keep doing our math. This gives us a 10.5 over 3, which gives us an average rate of change of 3.5 for our f of x function. Now we're going to do the same thing for g of x. We need our ordered pairs with -5 and -2. So we go up to our table of values. When x is a -5, our g of x function is this one over here. It's that -37.5. And when x is a -2, our y value is a -6 for that g function. Now we find our average rate of change, y2 minus y1. So -6 minus a negative turns into plus 37.5 over -2 minus a -5 turns into plus 5. That's going to give us a 31.5 over 3. We divide that out and we get an average rate of change of 10.5. And that makes sense. We knew that our g of x function with, the absolute value a is a bigger a value. It's going to be more stretched, so it will have a greater rate of change, average rate of change. What we do notice is the average rate of change of our g function, 10.5, is 3 times the average rate of change of our f function, which is 3.5.